if we have extra time. So what is matter? If you've taken middle school, which hopefully you have, you've probably learned about the 3 states of matter. Well, there's actually 4, actually 5. We're only going to go over 4 of them. All matter is made of atoms. If it's not made of atoms, it's probably not matter. And you probably are going to know that pretty much everything around you is made of matter, but there is something that isn't made of matter, and that would be light. So the light you're looking at the screen right now, that's technically not matter, even though you can see it. So you're made of matter, you matter, something like that, yeah. Now, 4 states that we're going to cover in this class: solid, liquid, gas, plasma. Really, all we care about is plasma right here. That's the only one. Sure, solid, liquid, gas, they're kind of important, but it's just not going to be important for what we're covering. So if you take chemistry next year, yeah, you're going to be going over these 3. But really, I just need you to know that plasma is atoms that have been ripped apart, really. So the protons, neutrons, and electrons have actually escaped each other. So here you can see there's positives, there's negatives, and they're not together. Whereas in the other 3 states of matter, all the protons, neutrons, and electrons are clumped together in an atom. Now, solids, liquids, I don't think I need to cover this very much. You probably already know solids, definite shape and volume, something like this USB flash drive, right? It's not changing shape in my hand. It holds its shape. Liquids, they can move around, fill a container. And then gases, they have enough energy to move independently, but they're also attracted. Now, you've probably heard, sun or stars are big balls of gas. That's mostly wrong, actually, because the sun and stars are mostly plasma. They do have gas, don't get me wrong. In fact, the surface is mostly gas. But inside the star, it's pretty much all plasma until you get to the outside layers like the photosphere. So what is plasma? And you'll notice I've color-coded the notes. That's just leftover from when we were in person. It's the same things that are color-coded in Canvas, so you'll have them twice. So for plasma, it's the most common state of matter in the universe because, well, stars are made out of mostly plasma, and there's a lot more stars, or a lot more stuff in stars than there are in planets. I mean, the sun can hold 1 million Earths inside of it. There's a lot more plasma. You can actually make plasma at home. I actually would demonstrate this inside the classroom using a microwave, but if you're gonna do this, just keep in mind you may slightly damage your microwave over time, so don't do too many times. You can put grapes next to each other, and as the atoms in the thin sheet between the grapes actually heats up, it'll rip the atoms apart and become plasma. Temporarily, of course. It won't stay that way once they cool down. So plasma, all you got to do is just heat something up high enough, and as it gets super hot, the atoms, the electrons will just float away, really. Okay, so quick refresher. Sorry if you've taken chemistry before, but this is not as intuitive as you think it is. 3 parts of an atom: protons, neutrons, and electrons. So inside the middle, the nucleus, is the protons and the neutrons. And you can see the protons, they are positive, so there'll sometimes be a positive charge there. Sometimes there's a P. Don't get confused if you see a standardized test or a Canvas quiz on that. Neutrons will either be a blank sphere, or there'll be a 0 or an N. So any of those 3. And electrons will either be a negative sign, or an E, or just a dot in the outside shells. So you might see all 3 of those. And in fact, if we bring up the other program, I'll bring it up in a little bit. So if you bring up a program that we use for the class, they actually use just a plain old sphere for theirs. So if I throw an electron, it's just a sphere. That's an electron. So keep in mind, you might see all 3 of those. Now, what are elements? You might see the word element. An element is just one type of thing, like gold, a gold atom, a bunch of them, or silver, or hydrogen. So in this case, we have a hydrogen element right here. And as long as it's just hydrogen, not anything else digging into it, not H2O like water, we can call it an element. Now, what tells you an element? Only the number of protons. So let me show you something on our build an atom PHET back over there, and let me explain what that means. So if I throw a proton in, notice how it says hydrogen up here, H for hydrogen. No matter how many neutrons or electrons that I throw in, it does not change what that element is. It is always hydrogen, no matter how many of these I throw in. Now, this atom will never exist in real life. There's no way hydrogen could have, 7 neutrons. That's not going to happen. But until I throw another proton in, it will stay hydrogen. So the protons tells you what it is. 1 proton hydrogen, 2 protons helium, 3 protons lithium. That will never change. Okay. So you're never going to have a hydrogen that has 2 protons. It's not hydrogen. We define that as helium in that case. So that's one key thing to remember. A few people have actually turned in their assignment and they said, oh, you can add another proton to make it positive. Well, no, you can't. If you add another proton, you've changed the element. It doesn't just make it positive. Okay, so yeah, I kind of mentioned this right there. Adding a proton makes a new kind of atom. Adding a neutron, well, that does something different. Get out of there, Link. So adding a neutron will actually make an atom isotope. Now, those of you who taken chemistry, you know what an isotope is. Those of you who haven't, well, just know that an isotope literally means an atom with a different number of neutrons. We won't see much of it right now, but in module 1.5, well, the next module, we'll see more of that. So let's do a quick chat question. Not this one. There's 2 protons on here. So get your chat box ready if you haven't yet. And let me ask you this question. So on the count of 3, I'll ask you what this is. You can type it in, but don't hit enter yet. What atom is this? So get ready. 3, 2, 1, enter. What atom is it? All right, we can go ahead and stop. So a lot of people are answering, how many protons does it have? And those of you who are answering that, yeah, that has 2 protons. But what atom is this? That seemed to be a little bit more tricky. So let's build it. That's why we're doing this program over here. So we've got 2 positives, 2 neutrons, and 2 electrons. Let's put it in build an atom and see what we get. So I'm just going to refresh because that's one way to just clear it out. So I needed 2 protons, 2 neutrons, 2 electrons. Check it out. The atom is He, helium. So it's an element of helium. Now, keep in mind, even if I took the electrons away, guess what? It's still helium. Even if I took the neutrons away, it still says helium. So the only way to tell what atom it is what amount of protons it has. Now, I know you probably didn't have a periodic table in front of you, so that wasn't totally a fair question. But just know that when it comes to a single atom, if you type in H2O, that's actually 2 different types of atom. That's 2 hydrogens, 1 oxygen. So we're not going to go into compounds. Everything we'll be doing in this is just one single element. All right. So helium, 2 protons. All right, more about them. Elements, building blocks all matter. I think you already got that. Ah, yes, the formulas. So the periodic table, like this one right up here, can actually tell you directly how many protons, neutrons, electrons that you have. And it can tell you the atomic mass, atomic symbol, that kind of stuff. So let's take a look. Let's say you're given a periodic table, which you will see one of these on the quiz. I can already tell you right now. You're going to see one of these on the quiz and probably one on the final exam. Let's say you're given one of these. How can you tell the number of protons? Well, you use that number right there. That's the atomic number. So if you look on it and you see the smaller of the 2 numbers, and it would be really clear, it's always the smaller of the 2. It'll always be the whole number as well. Sometimes this bigger number can be a decimal. The smaller of the 2 numbers is the number of protons. Now, it's not always up here on the top. The atomic number could actually be on the bottom. It could be on the left. It could be on the right. So I can't give you a sure, fast method other than it will be the smaller number. So this oxygen has 8 protons. All oxygen always has 8 protons. What is that? That's the symbol. That tells you what's the abbreviation. So Fe is iron, O is oxygen, C is carbon. But of course, most atomic or periodic tables will have the name right next to it. Not all. If you take chemistry class, you might actually see you'll just have this and you won't actually have the name next to it. Especially college chemistry, they're very into having you memorize the whole periodic table for some reason. And lastly, we get to this bottom number or the bigger of the 2 numbers. It will always be bigger. Sometimes it's a decimal. That's the atomic mass and weight. And the formula for that is, well, hold on. Let me just stick with atomic mass plus weight. So that is the total number of protons and neutrons. And let's actually go back to build an atom really fast. And if you click down here, mass number, you can see it says mass number 4. And notice I have 2 protons, 2 neutrons. I throw in another neutron, it goes up to 5. I throw in a proton, 6. So my mass number is literally, what is the number of these things in the middle? Protons, neutrons. Notice electron, it's not changing my mass number right there. They just really don't weigh that much. So that's mass is number of protons and neutrons. What if you were just trying to find the number of neutrons? Well, you would use this formula right here. Now, I do have this in Canvas, but if you haven't spotted it in Canva yet, might as well write it down now in your notebook. To get the number of neutrons, you take the mass minus the atomic number, or take the mass minus protons, because we know that atomic number right here is the same as protons, and that will give you neutrons. So I'll give everyone a second to get that if you haven't yet, or to copy that to your memory. And then we'll actually go to build an atom and take a look at what that looks like. All right, let's take a look. So my mass number is 7. I wonder if there's some way I could cover this up. Obviously, it's a little bit clear because you can just count the number of neutrons in here, but I'll run it anyway. So my mass number is 7, and I have 3 protons. So 7 minus 1, 2, 3 will give me 4 neutrons. So it's easy here. Just keep in mind, it won't always be this easy. Now, we can do another example. Well, I can't. Let's go back to this one, actually. Nah. All right, we'll do one example later. Just know mass minus protons, or mass minus atomic number, equals neutrons. Now, if you're looking at a Bohr model, because I know the first assignment actually asked you to draw a couple of Bohr models. So there's a couple different ways I mentioned. You could do positives, you could have P's, but they'll always be in the center. You can't have a proton hanging out here by the electrons. That's not going to happen. They stick to the middle. Neutrons, they also stick to the middle. So you'll never have a neutron in these outer shells. They'll always be in the middle. They'll either have an N or a blank. And lastly, electrons will only be hanging out in these outside shells. Now, you won't always see a line here, but most of the time you will. Sometimes it'll just be blank, and you'll have to either draw your own line or just put like a dashed line you might see, or simply no lines at all. Electrons don't have to follow those lines, but they'll never be in the middle here. That won't happen. So there's the different ways you'll see these presented, either in a quiz or in chemistry class or in a program, or even build an atom, as you saw earlier. Here's an example that I have a little bit different. Electrons negative, protons positive, neutrons no charge in the middle, electrons on the outside. Now, you'll notice one thing already, is that all the electrons are hanging out in different shells. So let's talk about these electron orbits now. They have special rules. They can only hold so many in certain shells. So that first shell can only hold 2 electrons. After that, it's full. It's just not big enough to hold more electrons. Second shell can hold 8, and the third shell can hold up to 18. Now, those of you who've taken chemistry, you probably know about like electron orbitals and the S and the P shell. We're not going into any of that, okay? For geoscience, all we care about is, okay, this one holds 2, this one can hold up to 8, and it can hold even more on the outside shell. Now, it doesn't have to hold all 8. Take a look. This atom right here only has 1, 2, 3, 4, 5. So this is a nitrogen atom because it has 7 electrons and 7 protons. And you'll notice that it doesn't have 8. That's fine. It can hold up to 8. But the inside shell can only hold 2, and guess what? It's full. Max 2. Add a third one, it'll just go to the outside shell. Now, these are called valence electrons, the one in the outside shell. That definitely will come up in chemistry. For here, geoscience, that won't come up again until 3rd quarter, but it'd be a good thing to remember. Since valence electrons are really the only ones that do anything to do with chemistry, they're kind of important. The inside shells, the ones that are not, the electrons that aren't on the outside, they really don't do much. They kind of just hang out there and provide a balancing charge to the protons. So if you ever plan on going into college or taking chemistry, that might be something to commit to memory. The outsidemost shell of electrons are the valence electrons. And they can actually tell you kind of what atom you have if you have a periodic table with you. So let's try it in the chat. How many protons does this have? So we'll do a countdown. On the count of 5, type in how many protons does this atom of lithium or lithium have. 5, 4, 3, 2, 1, go. How many? Yeah, you got it. 3. Atomic number, it's the smaller of the 2. That's the number of protons. Nice. All right, let's get a little bit harder. You guys got that? How many neutrons? So on the count of 5, how many neutrons does this lithium have? 5, 4, 3, 2, 1, go. All right. Most of you got it, yeah? All right, just keep in mind for neutrons, mass, bigger number, minus atomic number, smaller number. So 7 minus 3 is 4. Okay. So this is actually the mass number, not the number of neutrons. Just keep that in mind. I guarantee we'll see it on the quiz. So hopefully everyone here gets it right. And how many electrons will this add? Oh, that's tricky. Okay, so on the count of 5, how many electrons will this atom have? 5, 4, 3, 2, 1, go. A little bit harder. All right. So electrons. Let me see if I have that. It is the exact same as the atomic number. So the atomic number is 3. It should have 3 electrons as well as protons. So it's the same. And in fact, I'll show you, because all we're dealing with this class is neutral atoms. We aren't dealing with like ions, really. Let me go ahead and reset this. Let's say I have an atom. And since we're only dealing with neutral atoms, check it out. If everything has to equal 0, the protons too has to equal the electrons too. So for lithium, we'll throw in some neutrons. They don't really change any of the electrons though. So for lithium, in order to get a neutral atom, my 3 protons have to equal my 3 electrons. So always the same in this class. Now, if you get to ions, chemistry, that will change. But for here, man, they're the same. So protons equals electrons. Oh yeah, I guess there's the answers. 3 protons from right there, 4 neutrons from right there, 7 minus 3 equals 4, and then 3 electrons. They're the same as the protons. Okay, one last thing, stability. You will see this in the assignment 1.5. So atoms can become radioactive. How do they do that? It all has to do with neutrons. They don't really do anything except for whether an atom is stable or not. So a stable atom means it'll stay the same pretty much forever. A radioactive atom means it will change. That's all radiation or radioactive really means. The atom will change. And nuclear radiation just means the atom will change from within the nucleus. So the nucleus is the center, and we have carbon 12, carbon 13, and carbon 14. So let me show you what that looks like, because build an atom can actually show you whether something is radioactive or not. So I've made myself carbon, and carbon 12 will have 6 neutrons. So if I click stable, unstable, notice it says it's stable. Nothing's going on here. Electrons don't affect stability. They just change the charge. Now, what if I make carbon 13 by throwing in another neutron? Well, carbon 13 is also stable. It won't really do much. And in fact, right now in your body, there's probably a few billion carbon 13 atoms hanging around there. You've got trillions of carbon atoms, but there's quite a bit that are also carbon 13. But what about carbon 14? I throw in another neutron and all of a sudden the atom becomes unstable. Now, all that means is after some period of time, this carbon will take that neutron and it will fly it out, and it will become stable again. So carbon 14 is all around us. In fact, there's even more carbon 14 than carbon 13. There's actually other ways to make it stable as well. But every once in a while, every 5,000 years on average, a carbon 14 will become a carbon 12 by getting rid of a couple of neutrons. Boom. Now, it actually does it a different way, but it's easier to show you that way in here. So that's what stable means. So when you see in the assignment, just keep an eye out for that. And other atoms can be stable, unstable. For example, let me refresh this. If you just have a hydrogen atom with 1 neutron, it's stable. But if you throw another neutron in there, it becomes unstable. So what about too few neutrons? That's a possibility too. Helium without a neutron, that's unstable. It needs neutrons. Otherwise, what will happen is this proton will go flying out. So protons don't like hanging out with each other. The neutrons hold them together. So the neutron makes it stable. And in fact, you probably want 2 neutrons on a helium. So that's stability. And that comes to the end of our notes.